Check 1, 2, hello, hello. All right. Let's get this set up. Let's do some class. Hello, her lord. Welcome.
Hello.
All right. So we're going to start off with a little bit of a review, I think, of what we had been doing a long, long time ago before the Ice Age hit. And that was factoring stuff and the common mistakes we make when we're dividing, right? This problem in particular was a great example of all that therein. This pen is garbage. Try this one. Much better. Okay. And then we had a time symbol here, and it was 3xy all over x squared plus 2xy. It was this thing, right? And so we don't have two separate terms here and here necessarily, right? Because there's a times symbol in between. But we do have separate terms in the numerator, and we do have it on the bottom. What's up, Bon? So the first thing we want to do is, instead of just multiplying these, which you could do, right? You could just do 3xy times both these terms. Again, right now we're just reviewing, right? This times both terms, you could totally do that, right? There's a lot of stuff there, stuff that you might notice can divide out, right? So simplifying first is almost always a good idea, right? Because it's simpler to work with. So instead of looking this way, multiplying across immediately, we'll do that later. First, let's try to divide out common terms in the top and bottom. By common terms, I mean common factors, right? Now, the safest way to do this is to not just see like, ooh, look, there's a y here, there's a y there, just cross them out. Doesn't work that way. There has to be a y in every single term to do that. The reason for this is because really what has to happen first is you have to factor out that y and turn it from two terms into one term. So let me show you what I mean. So on this right side right here, 3xy is all one term. That's not a problem. The problem is in the bottom, it's two terms. But if I factor, I am condensing it from two terms to one, right? And the way I can do that is I can see that I can't take out a y from both. I can't. But what I can take out is a single x. So I'll get x plus 2y. And the reason for that is because if I were to do the reverse, if I were to expand, right? If I were to distribute, I'd get x times x, which is x squared, and x times 2y, which is 2xy. So it's the same thing, just different way of looking at it, right? It's like taking the number 12 and turning it into 3 times 4. Just a different way of looking at it, same thing. So what's nice about this is that technically, the bottom is not two terms anymore, right? Yeah, there's a plus sign in the middle, but this is all in parentheses, meaning I'm supposed to treat it as if this were all one term, right? So I have x times something. X times something is one term, right? 5x is one term. 3x is one term. 12y is one term. xy is one term. So x whatever is one term, right? Hello, Hadley. I love your picture. Hi, Casey. So now we have all one term in the bottom technically, right? Because this plus is in parentheses. And so now we can divide safely. And the reason we're dividing, by the way, is not because we're factoring, right? If I just gave you this and told you to factor that, you would just pull out an x and we'd be done, right? The reason we're dividing is because there's this giant division bar here, right? It says divide. And in order to divide, we have to have it all multiplication and division to do it safely. And now we do, right? This is all multiplying, and this times this is multiplying. So now I can divide out x and x, because anything divided by itself is Juan, right? And that's as much as I can divide out on the right side, because look, there's nothing else I can factor out here, because we have to factor because there's two terms, right? And of course, 3 and y have nothing in common with this. Just because there's y's doesn't mean they cross out, right? So over here, we can't factor out a variable right from the top, because this one's x's, that one's y's, there's nothing there. But we can factor out what? Now we do the delay check, right? How far is there a delay? What can we factor out from the top here? This is a review, so hopefully this looks familiar. Hopefully I'm not boring you too much. You may type in or speak using your microphone. Oh, wow. Okay. I saw that.
I got it, Mr. Mac.
Yeah? What can we factor out? Oh, let me mute the speaker so you're not hearing feedback. There we go. So what you got?
We can obviously take a 2 out.
Take 2 out. When we do that, we get x plus 2y left over. You should always check, is this still the same thing, right? Is 2 times all that the same as this? If we double this, yeah, for sure, right? If we double the x, we get 2. If we double the 2y, we get 4y, right? Same thing, right? Just different way of looking at it. And now we can divide these out. I'm actually going to factor this 8 into 4 times 2. And the reason I'm doing that is so I can see clearly that these will divide out. Anything divided by itself is 1, right? If you didn't want to do that, you could divide the 2 and the 8, leaving this to be a 1. And the 8 would just be a 4, which is exactly what happens, right, when we're done here. So now I would say let's multiply across, right? Because when we multiply, we're multiplying across, not cross. We're not doing that, right? That does not work. It's not what's going on here. This times 3 times y is what's happening. So if you're not comfortable, you could just write it like this before multiplying, right? That whole thing times 1 is just that, right? And then we're timesing it by 3 times 1 times y, which is just 3y. All over. In the bottom we have 4 times 1, which is 4, times 1, which is 4. And then we're timesing it by x plus 2y. And at this point, you should notice something. Before, there was nothing else we could divide out here, right? There's nothing else we could divide out here. We factored as much as possible, but by combining these things, we ended up with common factors, right? We were supposed to divide by x plus 2y, that whole thing, right? Not just x, not just 2y, but x plus 2y. Treat it like it's one term. And we can do that now. This whole thing divides out with this because it's all multiplication and division, right? Again, this is all one term. It's in parentheses. And we're timesing by 3y. That's just one thing, right? Divided by 4 times something. Again, just one thing. We can divide out those somethings in their entirety. And so what we end up with is 3y over 4. And we know that's simplest form because there's nothing else we can divide out from 3y and 4. They have no common factors. So the big brain play here, right, is to make sure to factor before you divide out, because otherwise you might make a common mistake of dividing out y's, right, which doesn't work. There aren't y's in every term here. So if you catch on to that idea of, oh, it has to be in every single term, sure, right, that can get you around the factoring stuff, but you still might miss stuff like this later on, right? This extra factor that shows up after we factor things out, right? So my advice is, before you divide out expressions like this, always factor first. It'll save you a lot of trouble. You will become a god at this type of stuff. Now, let's move on to something else. We're going to take a look at section 4.4 now, entitled Fractions. I'll show you what I'm looking at right now on my screen. This is it, right? It's on page 115 if you want to follow along. There are books on Google Classroom now. It's the first thing under classwork. So you could look at that. Or not. Like, I've got like 3 different monitors here. You guys don't, right? But there it is, right? And we're just going to go through these 3 problems. So that's all there is. There's just 3 problems here. Like we would if we were in class, except we're not going to have board work as much. So if you want to get out some paper and pencils and write some stuff down, take some notes, cool, right? We'll do it old school lecture style. The reason I don't like doing lecture style is because typically one of the main problems is that I'm doing all the thinking, you guys aren't. But you can join me on this journey. It can work, right? As long as you want to be here and you actually want to learn, right? And that's a lot to ask for a class of 30 random kids at a random time during the day, right? But here, hopefully, you know, being 11:10 a.m., hopefully you're awake by now. Sorry that, you know, you guys got the a.m. slot, but you guys are the younger kids. That's just how it goes. But yeah, if you want to follow along with your brain, if you want to write down stuff, that's cool, right? But make sure, more important than the writing stuff down, your brain is doing the thinking, right? Because if you don't do the thinking and you write the stuff down, worst case scenario is probably the same as best case scenario. You're not going to know anything that you're writing down. It's going to be a bunch of gibberish, and you're never going to look at it again anyway, right? So it's almost like you weren't even here. So my advice is, more important than taking notes is make sure you're present and thinking. And then when we're done with a problem, maybe you want to write down a few notes to yourself about things that you want to remember. Like that last problem that we did with all this junk. Again, giving you guys some time to get stuff out if you want. With all this, I wouldn't probably write all this down if the main lesson was, here's the problem, make sure you factor first. And maybe I make a note about how y's don't divide out, right? I wouldn't even write down the whole thing. You guys have the answer and how to do it in your book, right? So if you really wanted to look at it, you put the problem number next to it. That was problem, 4 point whatever, right? You can go look it up later. Saves you time about writing, gives you the stuff that you really want to remember, and you're back in the action, right? So speaking of back in the action, we're looking at 4.4 fractions. 411. Hi, Esteban. 411 is the problem we're looking at. And it says, write, and I'll write it all out for you, write 2 over r plus 3 over s as a single fraction. So it's important to read the directions in algebra, because unlike in regular pre-algebra where it's like 3 plus 5, what do they want you to do? Probably add them and say 8, right? Algebra has different rules depending on what they want you to do, right? Sometimes they want you to factor it, sometimes they want you to solve for x, right? There's lots of different things. Some of you guys already know how to solve this. It says write it as a single fraction, so we want it all over one denominator. And that's because the reason you guys probably know how to do this already is because you know how to do it with regular numbers, right? So side problem, side problem, side problems. If I had 2/5 and I was adding 3/9, you know what to do, right? We need common denominators. These aren't the same thing, so how can we add them together? They're apples and oranges. You would know to multiply by 5 over 5 here, because that won't change it, right? Has to be 5 over 5, not just 5, because timesing by 5 would make it 5 times bigger. 5 over 5 is just 1, so it's not going to make it any bigger. And of course, timesing by 9 over 9 is also 1, so it's not going to change the problem. What's up, Jackson? So this won't change it, it'll just make it look different. We would get 18 over 45, and of course over here we'd also get 15 over 45. We get the same denominator. Of course we would, right? Look at it. Right, it ends up multiplying by itself. We're multiplying each other's denominators. And so we can now say in total how many 45ths we have, right? So I've got 18 and 15. That's 15 plus 15 plus 3. You follow me on that? 15 plus 15 plus 3, so 33. 33. We can check to see if that simplifies either here or here. Personally, I like doing it before I add them all up, because I know 15 is just 3 times 5. And 45 is 9 times 5. So 5 is divided out. And hey, look, 3 over 9, I can divide that out and get 1 over 3, right? So I got 1/3. And then over here, I can also divide out stuff. I've got 9 times 5, and I've got 9 times 2. Now you'll notice if I do this, I get 2/5 and 1/3. Now I don't have common denominators again. Well, I could go back through that and times by 5 over 5 and 3 over 3 if you wanted to. That's fine. Or you could just go here while we have a common denominator and rewrite this as 3 times 11. And I can write this as 3 times, and I know it's divisible by 3 because if I add up 4 and 5, I get 9, right? That's a trick you can do with 3s. If you add up the digits, you can divide, and you can divide that number by 3, the whole thing's divisible by 3. So 4 plus 5 is 9. 9 is divisible by 3, so is 45. 3 plus 3 is 36. Or sorry, 6. 6 divided by 3 is 2, so yeah, that'll divide, right? So it looks to me like 3 and 15, because 30 and 15 makes 45. 3's divided out, I get this, 11/15. But back to the main problem. Again, maybe you learned that little 3 trick there, that you can, 1 and 5 make 6. 6 is divisible by 3, so 15 is divisible by 3. That's 9. 9 divides by 3, so 18 is divisible by 3. That's a nice little one. Let's go back to the original problem. How am I going to get common denominators? Again, using this reference right here, how did I get common denominators there? What am I going to do here? 2 over r plus 3 over s. How am I going to get those common denominators? Who's got it? Delay check. Who's got it, chat? Who's got it? Oh, and feel free to add little emojis or whatever over here on the side. I think Google Meets has that.
Hadley, I think you got it.
Hadley's got it?
Yeah, she definitely does.
Okay. Thank you for volunteering, Hadley. That was very kind of
I
you.
don't got it, man.
No?
I don't know what she's on.
Well, let's take a look. Here, when I had 2/5 plus 3/9, how did I get common denominators here? What did I do?
Multiply by 1.
Mm-hmm. And there's lots of ways to multiply by 1, right? 2 over 2, 3 over 3, 4 over 4, 5 over 5. How did I know to multiply by 5 over 5 and 9 over 9? Where'd those numbers come from? Chat.
Well, you have 9 and 5, and 9 and 5, so then they'll equal the same thing.
I need these numbers to match on the bottom, right? So if I times 9 by 5 and 5 by 9, I'll get the same, right? So I can use that same logic here. Even though they're variables, I can multiply by r over r, because anything divided by itself is 1, and I'll get SR in the bottom. Now to make sure this is also SR, right, because they got to match, I can multiply by S over S, because again, I don't know what S and R are. RR. But I do know they divide and make 1, right? What's up, Milo? Excuse me. So when I multiply this all out, multiplying across, I get 2s over, I'll write r then s because alphabetical. That's just me. And then this is r times s as well in the bottom, and I get 3r. So it's not one fraction yet, right? They want it as a single fraction. This is still two fractions, but because the denominator is the same, just like in this example problem, the denominators are the same, right? I can just write it as all over 45. So here, I can write it all over rs. Now, you might notice at the top, 2s plus 3r, you can't combine those, right? They're not like terms, but I can still write it like this, 2s plus 3r, and all I got to do is make it one term, right? One fraction. And I did, so I'm done. Can't make it any simpler than that, right? 2s and 3r can't combine, but it's one fraction, so we're done. It's all over one denominator. How we feeling about that, chat? You feeling okay?
W's in the chat.
Okay, W's.
Good.
Yeah. W's in the chat. Dubs in the chat. We're going to take this idea and we're just going to take it up a notch, right? That's what this book does, right? So that might be like a basic example. Here's something with a little bit more kick to it. So we got this fraction and we're subtracting this fraction. Now subtraction can be tricky, so we got to watch out for that. But the same thing applies. Thanks for all the dubs. We want to make these denominators match. Now, pause. Using the same idea we used last time, you could do this. You could. There is nothing wrong with this. I'm going to times by 6x squared over here, over 6x squared. So now I'm going to get this times that, right? And then over here, I'll multiply by 3xy all over 3xy. So my denominators match. Do you guys see that? Right? They're going to match. That works. That's fine. That works. But you're going to have a lot to simplify later because it turns out there's an easier move. So let me write it again. Think about what we're missing from this denominator. And think about what we're missing from this denominator to make a match. Well, that's if we just had 6 and 3, I think you would see that if I just times this one by 2, they match, right? So instead of multiplying by all this stuff, I'm going to multiply by 2 over 2. And that'll make that match 6 and 6, right? Now, notice this has 2x, x squared, right? So x times x is what I have over here. I only have 1x. So I'm going to multiply over here by x over x so that I get x squared on the bottom and 6. So I got 6x squared y now on the bottom here, right? This isn't 6x squared y, but I can make it 6x squared y. All I got to do is times by y over y. So you got to think about what each one's missing, and this will be easier to do than this. Look at all this stuff up here, right? Look how unnecessary this is. I get an extra 3 and an x up here than I do down here, right? That's extra stuff I'm going to divide out later, right? Here I've got an extra 3 and an x as well, right? All that stuff's going to divide out later. So save yourself some trouble. Just think about what's the smallest move you can make to make them work. Well, I need this to be doubled, so it's a 6. I need this to be times x, so it's x squared. And in order for this one to have a y, I got to times it by a y, right? Now, this isn't going to change anything because, again, I'm times it by 1. Y over y is 1. 2x over 2x is 1. So now when I multiply across, I'm going to get 5y squared in the top. Again, a lot of you guys are saying that's 2y. 2y is y plus y, right? Y squared is y times y all day, every day. In the bottom, I'm going to get 6x squared y, keeping it alphabetical there. And, of course, I should get the same thing over here, right? That's why I did it. So let's check. 6x squared times y. Same thing. That's why we did it. Then we got 4 times 2 times x, which is 8x. And we still got that minus sign in the middle there. So again, they want us to write it all as one fraction, right? In order to do that, we have to have the same denominators. So here's our denominator now. It's all over this, right? So in the top, I'm supposed to minus them. So instead of putting a plus sign between them, I'll put a minus sign. This minus that, whatever that is, that much out of this is kind of what's going on there. And there's our fraction. So again, let's break this down. Let's break this down. First thing we want to do, we want to make sure they have the same denominator. Otherwise, we can't make them all one fraction, right? To do that, we can multiply by each other's denominators, right? That'll work because they'll match. 3xy times 6x squared is the same thing as 3xy times 6x squared. But there's extra stuff in here. What extra stuff? Didn't need that, turns out. Again, an extra 3x over here as well, right? We multiplied by too much. It'll work, but you'll have to divide it out later. Here, if we make the smallest move possible, there'll be no simplification to do later. We multiply this all out, we get this, and we're here. That's it. Now, I want to show you what would have happened here, because I know a lot of you guys are a little curious. What would have happened if we just done this? We've got a little bit more work. If I multiply, I get 15xy squared, and here I get 18x cubed y. Over here, I'll also get 18x cubed, x to the third, right? X cubed, y. So they'll match, it worked, right? Minus 24x squared. So when I put these together, I'm going to get 18x cubed y, and I'll get 15xy squared minus 24x squared. And remember earlier we said we had extra 3x, right? We didn't really need that 3x there. We didn't really need that 3x there to make 6x squared, right? Check this out. If you notice, we solved the problem, right? We got it all as one fraction. You could circle that and be done with it. However, look in the top. We got two terms, right? We can factor something out here. I'll give you a hint as to what it is. It's that extra stuff we didn't need, right? I can factor a 3 out of the 15 and the 24. And an x out of this, right? So what I'm left with is 5y squared, because that's 15xy squared, minus 8x, because that would be 24x squared and negative, right? In the bottom, I can also factor out a 3 and an x, and then left over with 6x squared y, right? Because that's still 18x cubed y, right? And look, the extra stuff goes away. You'll notice that answer right there is the exact same answer we got here, right? We just had to do more work to get to it. Now, because the only thing they wanted you to do was make one fraction, who cares if it's not simplified, right? That's not what they asked for. But the reason we're learning this is to make math easier to work with, right? To look at things in different ways. So you probably would prefer the simpler looking thing, right? I'd rather work with this thing than that. Especially if the next thing I told you was, hey, plug in some numbers for x and y. I'd rather plug them in here, right, than up here. Bigger numbers, cubing, right? Avoid that if we can. So again, what are we doing? We're getting those common denominators, right? One way to do it is multiply by each other's denominators over each other, because that's just one, that's just one. Another way is to observe, what can we get away with, right? I need that to be double to make it a 6. I need this to have an extra x to match up. Cool. And I need this one to have a y to match up. Multiply across. 5y squared, 6x squared y, 8x, 6x squared y. Matching denominators, write them all over. All right, we're going to up the ante one more time. One more time, then we're done. That's it. That's all we're doing. Then we'll open it up for questions. We'll try some example problems together. And I'll write you out some answer keys for you to try, right? Just like we would on the board normally. So this next one, it says, in this problem, here, let me show you. Let me show you. This one down at the bottom here, 413. It says, in this problem. So you know whenever they say, in this problem, we blah, 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 they're showing you how to do it because it's an extra tricky one, right? So they've got part A, part B. Those are the steps to do, kind of, right? So in this problem, we're writing 2a cubed over a cubed b plus 3b over a minus 1 minus 3b minus 3 all over 6ab minus 6a as a single fraction. So before we start, what's different about this one versus the last two? What's different? I see two big differences, personally. Who's got one of them? What makes this one more difficult, you think?
It's a lot bigger.
It is, right? We got 3 terms, right? So in 411, we're adding 2 fractions.
Good job, Cole.
412, we're adding 2 fractions. 413, we're adding 3, right? So we're going to have to get common denominators. That's going to be a little weird. It's the same thing, right? It's all the same thing, right? What's another thing that's different? This one actually goes back to what we were reviewing a bit. I'll write it down while you guys are thinking about it. We got 2a cubed all over a cubed b. That's not so weird. Plus 3b all over a minus 1. That's a little weird. minus 3b minus 3 all over 6ab minus 6a. That's definitely the weirdest part of this. First term's not that weird. That's not that much weirder than what we were doing earlier, right? But the second term and third term especially, right? They got something going on that the others don't. If you see it, let me know. And if you don't, no big deal. I'll give you about 30 more seconds. Does have something to do with what we were reviewing earlier. That made those problems a little tricky. Oh, just marked up my brand new sweatshirt. Hate when that happens. Gotta get that thing in the wash. Love this sweatshirt too. Dangerous. All right, I'll show you. This one's not so bad, right? This is where things start to get weird. We have two terms on the bottom, right? Gotta watch out for that. Same thing here. We have two terms on top and on bottom, right? So that's a little weird. Part A, if you look at the directions, it says simplify each fraction if possible. So like what we were doing earlier when we were reviewing, right, where some of you guys came in a little bit late. Excuse me. We want to simplify these first because the simpler they are to work with, the easier it'll be, right? So let's just look at this. First, we factor. I noticed that this is all one term, and that's all one term. So it's basically factored. We're done, right? We can now divide or multiply in any order we want. So let's divide out those a cubes, right? A cubed divided by a cubed is 1 over 1. So what we end up with is 2 times 1 over 1 times b. Now here, there's nothing we can factor out of the bottom here, right? A and 1 have nothing in common. There's nothing we can divide out, right? If we can't factor the bottom, then we can't divide. There's just nothing. Also, even if you were trying to, A and B don't work together, right? It's just not how it works. So this is in simplest form, 3b over a minus 1. Now, for this next one, there are some things we can factor out of the bottom. Now, just because you can factor doesn't mean things will divide. You got to double check, but they will end up dividing. Now, if we look at the top, we can factor out a 3, right? So we get 3 times b minus 1. 3b minus 1s is the same thing as 3b minus 1, right? If we have 3 of these things, we'll get this. Checks out, 3b minus 3. In the bottom, who's got the factorization in the bottom? Who's got it? While I try to quickly clean out this marker. Who's got the factorization in the bottom? Esteban's showing up period 1 right now. 8th graders getting dunked on.
3.
I can definitely take out a 3. If I take out a 3, I get 2ab minus 2a. And I actually like that factorization because you might notice we could take out something else, right? A 2. But 2's not going to divide out with this. So I like leaving those 2's there. That's fine. That's fine. 3's will divide out. And the reason they're dividing is because we got a division bar, right? Just because they tell you to factor doesn't mean they would divide out. But we got a division bar. 3's will divide out. Now we're here. Now you might notice there is something else that could divide out. And it would be an a. So we have b minus 1. If I factor out an a from both, notice there's no a in the top. So it wouldn't divide out. Same thing with the 2. You could factor out a 2, you could factor out an a, right? I'll write that over here. You get b minus 1 all over 2a times b minus 1. Oh! So 2, if we factor it out, isn't going to divide with anything, right? A, if we factor it out, it's not going to divide with anything. So why do it? But look what happens when I do. What do you see? What do you see? What is going to divide out? 2a is going to divide out. That's true. So, 2a is going to factor out, right? I took out a 2a. What else? Look closely. That actually, something does divide out. What divides out?
You can cancel out the b minus 1.
For sure, for sure, for sure. So, just because it doesn't look like anything's going to go away, right? Oh, yeah, if we take out a 2, nothing will divide, right? There's no 2 up there. Take out an a, well, there's no a up there. So what's the big deal? Do it anyway. fully factor first. There might be some stuff in here you don't realize divides out. B minus 1 is in both terms, right? It's in this and it's in this, it turns out, right? So always fully factor. That's what we were talking about earlier when we first got here, right? Factor before you divide. Because a lot of you guys probably saw, oh, look, I'll divide out 3's, right? Make those 2's, make those 2. That's cool, right? But you would not have seen that we also have this, 2a, b minus 1. Factoring out a 2a from both. 2a times b, boom. And then 2a times minus 1 gets us back to that minus 2a, right? So yeah, the thing we factored out doesn't divide out, but what's left over does. And you would have missed that, right? So don't just be going around marking off stuff that you think divides out. Oh, look, there's a 3 in every term. Mr. Max said as long as it's in every term, we're good. I also said make sure to factor fully because you might not see the other things that divide out. So now our problem looks like this. Oops, minus sign, minus sign, minus sign. B minus 1 divided by b minus 1 is 1 over 1. So we end up with 1 over 2a times 1, which is just 2a. Right? Those things don't go away. They become 1 over 1, right? So that's a 1 there. 2a times 1 is this. Now, this problem is still a little weird, but it's way less weird than what we started with. Right? We had 2 different terms, top and bottom on this one. We still had 2 terms there, right? Now it's all 1 term here. That's way easier to work with. Just like on the last one, you could have started right here trying to get common denominators here. Multiply this by a minus 1 over a minus 1. Multiply this by a cubed b over a cubed b. Get those common denominators, whatever that is, multiply it by this. But it would have been a mess. Now that we've simplified down and factored out as much as we can, right? Nothing divides out here. Nothing divides out here. This isn't factorable, so I can't divide anything out, right? Now, let's just take it bit by bit. Let's try and get these 2 to match first. These 2 right here. What I'm gonna do is I'm gonna multiply by a minus 1 over a minus 1 to make these match, right? Because that's the only way it's gonna get that matching, right? There's nothing in common here. I can't do a small move to make it work. I gotta multiply the whole thing. And then multiply this by b over b. And what I end up with is 2 times all that. Now, I told you 2 terms, right? That's what makes this one more difficult, because it's got multiple terms here, here, and here, right? When we double this, we're doubling up the whole thing, right? So we're doing this, 2 times all of a minus 1. All over b times a minus 1. And you might notice those divide out. Yeah, they divided out here too. Remember, we're trying to get common denominators, so hold on, hold on. B times the bottom is this. See how they match? And b times 3b is 3b squared. So now I can put those together because they have the same denominator. So I'm going to do that. We've got 2a minus 2 plus 3b squared all over the common denominator of b times a minus 1. Right? That's just 2a when I distribute minus 2 plus 3b squared. Okay? And they have the same denominator. So all that becomes this. Now we still have this thing. And they do not have common denominators. But we know how to do that. I'm going to multiply this by b over b times a minus 1. And b times the quantity of a minus 1. And over here, I'm multiplying by 2a over 2a. And look, they're going to match up now. See how those are literally the same? So I'm going to get 2ab times a minus 1 for this one's denominator. And I'll get the same denominator over here. That's why we did it. In the top. Okay? In the top. 2a times all of that. Are you seeing that? 2a times all that. So we're going to do 2a times 2a. Well, actually, you know what? I'll do it like this. I'll show some extra work here. Just so you're comfortable. 2a times all that, right? 2a times all that. And then we got 1 times all that. It'll seem kind of silly, but I'm going to do it. 1 times b times a minus 1. 1 times all that. Okay? So we got our common denominators here. Got this. And then we still have to minus that. So we're going to get common denominators again. Multiply by each other's denominators. Make them match, right? And that gets us to here. So now what I'm going to do is I'm going to distribute that 2a and get 4a squared. Don't forget that squared. 2 times 2 is 4. A times a squared, right? That's not 4a squared. Then we get minus 2 times 2 is 4 times a, right? Double that 2a, make it negative. Then we get 2a times 3b squared. Well, that's 6 positive times a times b times b. Well, that's this. Then we've got 1 times b. Here, I'll put that all over this. I can distribute this too, but I'm not going to. 1 times b times that is just b times a minus 1. Oh, and let's distribute the b. We get ab minus b. So 1 times b is b times a is a, b times negative 1 is negative b. So we end up with ab minus b. Again, right in alphabetical, ab minus b. All over 2ab, a minus 1. I know you guys are getting tired, but class is almost over. We can make it. We got commie denomies. We distributed it all out. Let's subtract them. Let's see what combines. 2ab times a minus 1 on the bottom. 4a squared minus this stuff. We don't have any a squareds here, right? So I just got 4a squared. Negative 4a minus ab. Well, that's an ab, not an a, so I can't combine those. Minus a minus b. Well, I can't subtract b from 4a, so it looks like I just got minus 4a. Cool. Then I got 6ab squared. I don't have any ab squareds over here either. So it looks like I just have 6ab squareds. And then I still have to minus all this stuff, right? I haven't combined those with any of these because they don't match, right? A squareds don't have them. A's don't have them. AB squareds don't have them, right? So I got a minus AB. Cool. I'll do that. I'll just write that. And then the tricky part, I have to minus negative b, right? So that's really plus b. Remember, this means minus everything over here. So they all have the same denominator. Cool. And then I write them all over the top just like that. So I told you, this one's a little bit more advanced. We probably spent about 2 days on this type of stuff. Working it on the boards. That's our entire fraction. Now, pause just for a second, relax, clear your brain. We're going to back up and go over it again just real quick. I'm not going to hit every detail. I'm just going to give you the general idea. That way we can give you some problems to try and give you an answer key, okay? So here is the original problem, right? We simplified as much as possible. Those can divide out, right? Nothing divides out here, nothing factors out, right? Here we factored this. 3's clearly go away. But then we also noticed we can take out the 2a's. And what's left over divides out, right? So we ended up with this. We picked 2 to get common denominators first. We picked these 2. Multiply by each other's denominators, right? And after we did that, we ended up here. Right? That's what they combine to when they have the same denominator of b times a minus 1. Then we got common denominators here. You know how to make that work. Right? Multiply by each other's denominators. Distribute, distribute, distribute. This times 1. These match. We get here after you distribute, right? Then we minus all of that. So we're minusing the AB and we're minusing the negative B. So add B. Looks like nothing combines, so just leave it like that. That's it. The big brain play here for all 3 of these, the thing you really want to know, the thing you really want to get in your notes for all 3 of these is how to get common denominators, right? One way is to multiply by each other's denominators. That's what we learned in 411, right? Even if there's variables. 412, we saw, yeah, you could do that, right? Multiply by each other's denominators, but multiplying the right one by 2 and x, and multiplying the left one by y, right? We'll make a match. So you do that top and bottom, boom. Then the last one, how do you do it with 3 of them? First thing, always simplify, right? Factor things out, divide as much as you can, right? Simplify those down. They are fractions, they are division after all, right? Divide out as much as you can to make it easy. Then try to get common denominators. Pick 2, get them common. Then take those 2 and the last one, try to get them common. That's it. Now, if you're not feeling 100% on that last one, or even 100% on 412, that's okay. Learning and understanding takes time, right? So you're not supposed to feel at 100% right now. You're supposed to feel about 25% maybe. If you're there, that's great, okay? What you need to do now is get some practice so you can figure out which ones you're not feeling so good about and maybe make yourself feel about some other ones. So what we're gonna do, just like normal, we're gonna go to the end of the section, right? Here is how to do all those problems, by the way. Here's the first one we just did, 411, right? Here's 412. Here's 413. All right, see, they simplify first, crossing out all those things. Then we got the exercises before we head to the last section in chapter 4. So we got 4 problems. I'm gonna write you down an answer key for each of these. What I'd like you to do now, you can do it while you're still on stream, because you gotta wait for this answer key, right? I'll try to post it on Classroom, okay? I'll take a picture of what I'm gonna write down here. Take a look at those. I'm gonna write an answer key down. See if you can get those to be single fractions, okay? I'm gonna write an answer key down, and then when I've got it, I'll show you it, and then I'll take a picture of it, put it in Classroom. We'll call it a day, all right? So give those a shot. Start with 411. Think about how you can get those commie denomies. While you're doing that, like I said, I'm going to open up my answer key and then write it down for you guys, just like I would on the board normally. So let me open this up. And if you have questions, you may ask them now. Let's see. Chapter 4, Section 4. Really need to break this one down so it's easier to find. That's way too far. So again, give these a try. This will be part of your submission on Friday, right? And we will have a quizish on Friday. Will not be graded though. You'll see how it works then. Make sure you're prepared for it. But you'll see how it works. All right, when I'm done writing down the answer key for all these, I'll show it to you guys. First one's negative 4y plus 7x over xy. So if you already got that one done, you can check it there. But I'll show it to you in just a second. Only 4 problems. All these answers will be as simplified as possible. So if your answer is different, ask yourself if you can simplify it by factoring and then dividing, right? If you can't, then you might have goofed. Try to find that goof. And I will post this on YouTube. So if you want to go back and watch it again, take some notes. Or if you got friends that weren't here and they want to watch it, that way they can be ready. That's cool. 444. Okay, let me box these and then we'll show them to you. So you can take a screenshot if you want, or you can just wait for me to post it on Classroom, because I will take a picture of this and post it on there. So here it is. Let me zoom out. Here we go. There's 411, 441, 442, 443, and 444. So let me take a picture of this thing. Yeah. All right. Cool. So, all right, later, Esteban. Sorry, I didn't see that earlier. All right, so that's that on that. I'm gonna post this on Classroom. If anybody's got any questions right now, I can answer them. If you want me to show you how to do one of these, that's cool. I'll probably stay on for another like 3 minutes or so, unless somebody's got a question like that. So I'll post this to Classroom so they got the answer key, and then we'll let you guys go get some lunch, all right? All right, Co, are you good?
Yep, we're good.
Awesome. Later, kid.
Bye.
Bye.